my name is Kimberly Townsend, and I will be talking about the CBIR system using Curie by example. A CBIR is a content-based image retrieval system. The system measures the distance between a Curie image and a collection of images that is stored in a database known as a target image. How it works is a primitive feature is extracted from the Curie image. This includes images, the image's color, texture, shape, and spatial location. After this is done, the distance is measured between the Curie image and the target image. The target images are then ranked in increasing order of their distance to the Curie image. The ranked images are then returned to the user. This system can be used for a variety of applications, including but not limited to art, where they may use a CBIR to categorize art placement of specific sections in a museum, crime prevention, where they may use a CBIR for content-based face sketch retrieval, geographical information, where they may use a CBIR to extract fine features of a geographical image, and medical, where they could use a CBIR for medical image searching. The methodology for completing the CBIR Curie by example, or QBE, focuses on these three main steps. The first step is creating a function that would convert an RGB image to a 6-bit color-coded image. The second step would be to create a histogram to display all of the commonly used color function or features of the Curie image and target images. And the last would be to the last focus would be to create the Curie-based CBIR. The program itself has 5 files: myhistcount.m, rgb26cc.m, getDistance.m, createdb.m, and cbir.m. The setup of the folders includes a data folder. This holds an import folder, which has the target images, and a meta folder, which has 2 matrices that store extracted color code information. The source code folder holds all of the files for the program. This is my hist count. It is a function that displays the counts of in bin of the grayscale image using 2 input parameters. It also normalizes the counts by the image size. Here we have rgb26cc.m. This function takes an RGB image and returns a 6-bit color-coded image. Here we have getDistance.m. This function calculates the Euclidean distance between the 2 given points P and Q, where P and Q are 2 vectors of the same size. And here we have createdb, which creates the database for the project. It scans the import folder to retrieve file information. Then we have dataset size, which holds the size of the dataset. We have DB, which is the created database. And we have the processing of the images, which takes the image, converts it to a 6-bit color code, normalizes the data, and sets it in a histogram. Here we have CBIR. In CBIR, where we run the function, it opens a path for the target destination. Then we have specific file name where the user will pick the file. The file will then be loaded into the query image, and it will be stored as IMQ. It is then converted into a 6-bit color coded image and set to IM6CCQ. Then a query image histogram is created. Then we will load the database, create an empty object called D. The Euclidean distance is used for the empty object D. After the for loop is ran, it sorts the indexes, then sorts them by the top 20 indexes, and displays it in a figure window for the user. I can now show you how this program is ran. Here we go to the project. We go to the import folder where we select a image, and here is our output. Thank you.